Let's now talk about isolation levels. You can think of isolation levels as policies on how you want DB2 to work with locks. There are different isolation levels and the name are similar to the problems that we discussed earlier. So we have uncommitted read or UR, cursor stability or CS, read stability or RS, repeatable read or RR. You can set these isolation levels at different levels. You can set at application level or session level. Where the default is cursor stability, you can set at the connection level, you can set at the statement level. If you are using embed SQL, you can set it at bind time. For dynamic SQL, you can set it at runtime. So let's see an example. Application A needs to get a rough count of how many rows are in table. Performance is of utmost importance. Cursor stability isolation level is required. With the exception of one SQL statement. So for the particular SQL statement, you can use the with your clause so that just that one statement will run with isolation UR while the entire application still runs with isolation CS. So for example, you will run this statement as select count from tab 1 with UR. Let's compare how each of these isolation levels work in terms of holding and releasing locks. The figure shows a table on the left side with 6 rows. Let's see what happens when your application fetches rows from this table using different isolation levels. Let's start with UR on the right side. As you can see, in this case, no locks are taken as you fetch rows. Now let's see what happens when using isolation CS, which is the default. You fetch row 1 and a lock is taken. When you move on to fetch row 2, the lock is released from row 2 and a lock is taken on row 2. When you move on to fetch row 3, the lock from row 2 is released and a lock on row 3 is taken, and so on. Now let's see what happens when using isolation RS or RR. You fetch row 1 and a lock is taken. When you move on to fetch row 2, the lock in row 1 is still held and now a lock in row 2 is taken. When you move to fetch row 3, the lock in row 1 and row 2 still are held and now a lock in row 3 is taken, and so on. So as you can see, isolation level UR allows for maximum concurrency, while RR or RS allows for the least concurrency at the same time. UR provides the least accuracy in terms of results, while RS or RR provides the most accuracy. When using isolation CS, there are two different behaviors which are described in more detail in the next slide. The behavior that prevents timeouts or deadlocks more is the one where currently committed is enabled, and this is the default. The main difference is highlighted row number 3 in both tables. Without currently committed, a writer would block a reader. An update will block a select, so basically the select would have to wait. With currently committed, if you see on the table on the right a writer does not block a reader. So even if one application is doing an update on a row, another application can do a select on the same row. This slide shows the different behaviors when working with isolation CS. At the top, we will explain the behavior using CS. Without currently committed, and at the bottom, we will explain the behavior using CS with currently committed. So let's start at the top. Let's say an application A performs an update which will have to take an X exclusive block on the row. When application B running in CS without CC currently committed tries to perform a select on the same row, it will request an S shared lock which is not compatible with an X. Lock, and thus it will have to wait to the user. It will look as if application B is hanging. Only when application A commits or rollback will application B will be able to proceed with the select. Now let's see how's the behavior at the bottom with CS. Using CC, using the same case, application A performs an update and takes a exclusive block X lock. When application B issues a select on the same row, it is allowed to proceed, though it will retrieve the currently committed value. Which in this example was Susan. So in this case, the writer update does not block the reader select. Note, if app6 were using UR, the value retrieved would been John, which is the uncommitted value, but under CS, you only can retrieve committed values. This chart summarizes which concurrency problems are resolved by which isolation level. The loss update problem is resolved by all isolation levels. The table at the bottom provides you with an idea of when to use which type of isolation level depending on your application type and stability of your data, meaning how accurate you want it to be.